Hi everybody, this is Bowen here, and we're going to take a look at guided notes for standard 33, surface area and volume of spheres. We can look at our 3D figure here. A sphere is a ball, or you can think of it like the earth. It's totally round, it would roll. And when finding surface area and volume of a sphere, there's one measurement in particular that we need to look at, and that's our radius, which we are used to labeling as r. So we will have to identify the radius. Radius will be part of our formulas. And so for surface area of a sphere, for our formula, we will do 4 times the number pi times our radius squared. So keep in mind, pi is just a number. The only variable that we have here is our radius. And then for volume of a sphere, we're gonna have a fraction. We're gonna have 4/3 times pi times our radius cubed. And again, there's only one variable here that we're plugging in. We're plugging in our radius. Pi is just a number. These end up being pretty quick to type in your calculator because you can use the pi button in your calculator. Your calculator can also handle the fraction, 4/3. So you just have to be careful when typing it in. Let's jump to example A. Our directions tell us to find the volume and surface area of each sphere. If necessary, round to the nearest hundredth, or that means 2 decimal places. So in example A, look at our sphere, and the 2 meters is labeling our radius. That's given to us, so that's what we'll be plugging into our formulas. So we know our radius, and I'm gonna plug in. So surface area equals, I'm doing 4 times pi times my radius of 2 squared. So all I had to plug in here was my 2 meters for my radius. And then I can type this whole piece into my calculator. I can type 4 times pi times 2 squared. I can also do parts of it in my head. 2 squared is 4. 4 times 4 is 16. I could also just type 16 pi in. It's up to you. I would recommend just typing your formula as you see it and just be very careful typing it. When I do this, I get a surface area of 50.27, and then we cannot forget units. For surface area, our units are always units squared. So for this problem, we will have meters squared. And then for my volume formula, I'm doing 4/3 times pi times my radius of 2 cubed, or raised to the 3rd power. So the only thing I'm plugging in there, again, is my radius of 2. I can type this whole piece into my calculator. Be careful typing your fraction 4/3. I know Desmos Desmos Scientific Calculator allows you to type fractions, or you can always put parentheses around a fraction to indicate that it is a fraction. When we do this, we get 33.51, and for volume, we'll have meters cubed, or cubic meters. If we look at example B, the only thing that's different is I'm not given my radius, I'm instead given my diameter, or this is the measurement that cuts all the way across the circle. So I'm given diameter, so I would probably make a note that if your diameter is 17.4 meters, then our radius will be half of that. Our radius will be 8.7 meters. I'll take half of 17.4, which is 8.7. And so this will be the measurement that I'm plugging in. So I'll have surface area equals 4 times pi times my radius of 8.7 squared. All I'm doing here is plugging in my radius of 8.7. And I get 951.15 meters squared. And then for volume, I'm doing 4/3 times pi times my radius of 8.7 cubed, or to the 3rd power. And when I get this, I get 2,758.33 meters cubed or cubic meters. So just be careful, make sure you don't use diameter in this problem. We're using our radius here of 8.7. We took half of the diameter in order to find our radius. So at this time, I'd like for you to do U-tries 1 and 2 and see what you come up with. Go ahead and pause the video. Let's see how you did. On the first U-try, I got surface area of 28.27 square yards, volume of 14.14 cubic yards. On U-try 2, I got a surface area of 598.28 square yards and a volume of 1,376.06 cubic yards. We have one more example. So example C, our directions tell us to find the volume of each of the following objects. And if we look at these, we don't just have a sphere, we have kind of a funky looking object. And in example C, this looks a lot like an ice cream cone to me, where I have a cone on the bottom, and we were just working on cones. And then on the top, it's like I have half of a sphere, or you could call it a hemisphere, half of a sphere here. It's not a full circle, not a full sphere, but half of it. So in other words, I'm almost doing the volume of, you could say, the cone that's at the bottom plus half of the volume of the sphere that we see at the top. That'd be like the ice cream scoop. So again, here for my cone, I'm doing the volume of this cone plus half of the volume of a sphere, and the sphere is like the ice cream scoop here that's on the top of the cone. So I'm doing the volume of the cone plus half of the volume of the sphere. So I'm gonna have to find two different volumes here. Let's do volume of the cone first. So I'll say volume of the cone equals, and now we need to think way back to our formula for volume of a cone. And the formula we used was 1/3 base times height. And we could break that down a little bit more. Our base of the cone is a circle. And so when you're finding area of your base or area of your circle, you're doing pi r squared. So in other words, we're doing 1/3 times our base of pi r squared times the height. And then we can look at our figure here. I can see 9 meters here is labeling my radius. And then this 9 meters is my height of the cone. So I can plug in my radius and my height. So I would have 1/3 times pi times my radius we set is 9. So 9 squared times our height we set is 9. So again, here's me writing our formula, breaking it down a little bit more because we know our base formula for a circle is pi r squared. And then I can plug in my radius and my height of the cone because those are given to me. And then I can do this in my calculator. Keep in mind, pi is just a number. So I can type this whole long piece into my calculator. And when I do that, I get 763.41. Then I need to do volume of the sphere. So that's like the ice cream scoop, the half up there. So we'll just do volume of a whole sphere since that's what we just learned formulas for. So for volume of a sphere, our formula that we learned is 4/3 times pi times my radius cubed. And I just need to plug in my radius, which we set as 9. So I'm doing 4/3 times pi times my radius of 9 cubed. And that gives me 3,053.63. So I found volume of a cone, volume of a whole sphere, and then we could say down here, we're trying to find volume total, like our total volume. And we wrote that up here, that we would do volume of the cone plus half of our volume of the sphere. Well, volume of our cone is 763.41, plus we're gonna take half of the volume of our sphere, and our sphere volume is 3053.63. So volume of the cone plus half the volume of my sphere. And when I do that, I get 2,290.23. And because it's volume, it will be cubic meters or meters cubed. So do make sure you put units. That would be our total volume for this object, which looked a lot like an ice cream cone. At this time, you're gonna see what you can come up with for you try 3. So if we look at this object, I can see that the shape here is a circle and our radius is 2 feet. And I have a cylinder, it looks like in the middle of the figure. And then I have half of a sphere on the left and half of the sphere on the right. So really I have a whole sphere because I have half on the left, half on the right. So for this, you're gonna need to find the volume of a sphere as well as the volume of a cylinder, and you'll have to add those two volumes. So I'd like for you to take some time and see what you can come up with for you try 3. Go ahead and pause the video. Let's see how you did. So we mentioned that you have to find volume of a sphere, and it is a full sphere because there's half of a sphere on the left, half of a sphere on the right. So for volume of a sphere, I was using my formula, and I just had to plug in my radius of 2. So here I get the volume of the sphere was 33.51. Then I have to find volume of the cylinder, which is in the middle of the object here. And if we recall, our formula for volume of a cylinder is simply base times height. Our base is a circle, and for area of our base, area of our circle, we would do pi r squared times our height. And so I can plug in, my radius is 2, my height is 5. So for volume of the cylinder, I get 62.83. And so for my total volume, all I did was add my 2 separate volumes for volume of the sphere and volume of the cylinder. And we get a final volume of 96.34 cubic feet. If we flip to the back side, there are some more you try problems where you're asked to find the surface area and volume of each sphere. So that's what you'll be doing for numbers 4 through 11. Just pay close attention to if you're given the radius or if you're given the diameter. And then when you get to numbers 12 and 13, you have 2 more challenge problems where you're not necessarily just given a sphere, you might have a different figure. So I would like for you at this time to go ahead, pause the video and see what you come up with for these you tries. Let's see how you did. So here you can check you tries 4 through 7. Here are you tries 8 through 11. And then our last 2 were challenge problems. So on you try 12, you had to notice that this is half of a sphere or a hemisphere. So we had to take half of the volume of a sphere. So you could find volume of a sphere like normal. We were given our radius of 3. And then all you have to do is take half of that number. So our final answer should have been 56.55 cubic inches. And then you try 13 was the most challenging. This was a tough one. We have a sphere, a ball, embedded inside of a cube, like a box. And it tells us the volume of the outside cube is 4,096 cubic feet. We need to find the volume of the sphere that's inside it. So we can start out by saying we know the volume of the cube is 4,096. It would be nice if we could work backwards, knowing the volume of the cube, to find just what the side length is. And we know our formula for volume of a cube is the side cubed, or side to the third power. So if we're trying to work backwards and we're trying to undo the side length raised to the third power, we can take the cube root of both sides in our calculator. And when we take the cube root of 4,096, we get 16. So that means our side length of the cube is 16. So that means every side length, no matter how you look at it, all the side lengths are 16 on the cube. Because the sphere is embedded inside the cube, this side length of the cube matches the diameter, or the distance all the way across the circle that we see here of the sphere. And so the side length of 16 matches the diameter. Well, we don't want to use diameter, we want to use radius. So if the diameter of the sphere here, diameter of our circle is 16, we can take half of that, and then we know our radius is 8. And then I can use my volume of a sphere formula, which is 4/3 times pi times my radius of 8 cubed. And we get a final answer. Our volume for this sphere that's inside our box is 2,144.66 cubic feet.